All right, we're going to talk about the rational root theorem. So we're going to continue talking about rational roots, all right? At this point, when we're talking about polynomials other than quadratics, I don't care about your imaginary roots and I don't care about your irrational roots. We're going to focus on the rational roots only. So these are not the only roots of all of your functions. They are just the only rational roots of your functions. So sometimes your polynomials cannot factor, or it's not as easy to factor. So we're going to go through the rational root theorem here, and you see how that is helpful. So the rational root theorem says all rational roots of a polynomial in any function, in any format of a function where all these a sub n's are just some numbers, and your n and n minus 1, those are all exponents. So this would be something like 3x to the fourth plus 2x to the third plus so on and so forth until you get down to your constant at the end. All rational roots in that form where you have whatever your leading coefficient in that degree is, your largest degree, and you have a constant. What's in between does not matter. So if you have like 7x to the fifth minus 3, that's fine. You can't have 7x to the fifth minus 4x squared because there's no constant. Okay, so you have to have first term and a constant at the end. Then all of your rational roots are going to be some number, p divided by q, where p is a factor of your constant and q is a factor of your first term. Okay, so note, if p is a factor of this term, then negative p is also a factor. Like if you think of the number 4, 2 is a factor of 4. 4 divided by 2 is 2. Negative 2 is also a factor of 4 because 4 divided by negative 2 is negative 2. So when we get to these practice, you don't have to divide by all the positives and all the negatives. You have to divide by all the positives. And just remember that there are two answers, the positive and the negative of that number. Similar with q, that same thing. If one is going to be positive, one can be negative. So if p divided by q is a possible root, then negative p divided by q is also a root. All right. So we're going to list all the possible roots of your function. So your numerator are all of the factors of your constant. Here's my constant. What is every number that can divide 2? 1 and 2. And then I also need, what are all the numbers that can divide the first term's coefficient? Making sure your first term really is your largest exponent. This has a 3, 2, and 1. So this one, yes, is the number I'm looking at. They were not in standard form. Get them in standard form first. What are all the numbers that can divide 3? 1 and 3. So not all of the roots, but all of the possible roots are 1 divided by 1, 1 divided by 3. Okay, that's it for the 1. 2 divided by 1, and 2 divided by 3. And then you're going to reduce your fractions or simplify or divide if possible. It's like 1 divided by 1, that's 1. 1 over 3, that's just 1 over 3. 2 divided by 1, that's 2. And 2 over 3 is just 2 over 3. But if 1 is a factor, then so is the negative 1. So you're just going to put a plus or minus sign in front of all of your different possible roots. These are all of the possible rational roots of that function. That does not say that those are all of your roots or all of your rational roots. So those are the possibilities. It has to be in there. So 4, if I ask you, is 4 a possible root of this function? No, because 4 is not in this list. Okay, let's move on to the next one. There's a 1 in front of this t to the fourth, and my constant is 12. So 1 is easy. What are all the numbers that can divide 1? It's 1. 12 has a longer list. 12 can be divided by 1, 2, 3, 4, not 5, 6, not 7, not 8, not 9, not 10, not 11, but 12. And feel free to use a calculator to help you get there. Keeping in mind also that you should have technically pairs of numbers. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So the only way you can have an odd number really is if either you have just one, or if you have a number that multiplies by itself to give you that. So like 25 has factors of 1, 5, and 25. Because 1 times 25 and 5 times 5, you wouldn't list 5 twice. But otherwise, even set of numbers. So then you take your constant factors and divide them by your leading coefficient factor. So this is really easy. 1 divided by 1 is 1, plus or minus. 2 divided by 1 is 2, with plus minus sign. 3 divided by 1 is 3. I think you see where I'm going with this. Plus or minus 4, plus or minus 6, plus or minus 12. That one was pretty easy because your leading coefficient is 1. Once again, these are not all of the rational roots. These are the possible rational roots. Some of them are roots of the first function and some of them are not. And the last one. So factors of 2 are 1 and 2. I don't care about this negative sign because if positive p is a factor, then so is negative p. So being a negative 18 does not change the factors. So I'm going to ignore that for a moment. The factors of 18 are 1, 2, 3, 6, 9, and 18. Okay, a little longer list here. So the first thing is I'm going to take all of these and divide them all by 1. Right? Take all these, divide it by 1, so that gives me plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. But I'm not done because now I have to take all those and divide them by 2. 1 divided by 2 is 1/2. Okay, but 2 divided by 2 is 1. Now I've already listed it. I'm not going to list it again. 3 divided by 2 is plus or minus 3 over 2. 6 divided by 2 is 3. I'm not going to list it again. 9 divided by 2 would give you plus or minus 9 over 2. And 18 divided by 2 is 9, which I have already listed. Do not list them twice. So all of those are your possible rational roots of that function. Okay, let's talk about how to actually find them. So number 1, list all the possible rational roots using your rational root theorem, like what we did here. Okay. Step 1 could potentially be very, very tedious depending on how soon in your list you are, how lucky you are. You're going to start plugging in one of your rational roots into your function at a time and seeing if your answer is 0. So like there are 2 rational roots here, 1 and -1. I would plug 1 in for p and see if when I do 2 times 1 squared minus 9 times 1 minus 18, see if I get 0. And if I do, that's one of your rational roots. And if it's not, start over, do it again with -1. If that is equaling to 0, it is one of your rational roots. But if not, move on to 2 and -2 and then 3 and -3. Once you have one rational root, if one worked out, got it on the first try, perfect. Once you have your rational root, you're going to use synthetic division to reduce your function. If your new function is not quadratic, continue with your list. Try -1 and then 2 and then -2. You need to get it down to be a quadratic because once you have a quadratic, you could factor, complete the square, or use a quadratic formula. Now, it is possible that somewhere along the way you could factor by grouping or factor a cubic, potentially. You could try that as you're going, but it will not always work. Okay? It will definitely work when you get down to quadratics. Keeping in mind, though, I only want the rational roots. So, at some point with a quadratic, we have seen non-rational roots also pop up. So when that happens, you're done. I don't want the imaginaries. I don't want the square root that can't be actually square rooted, like square root of 2. Nope, don't want that. I only want the rational answers. And all of your answers should be these numbers in your list. So you might be thinking, okay, well, if I can just plug one number into your function and see if it equals 0, why don't I just do that with all my rational roots? Why don't I just do that with all of these numbers? Okay. But if you can learn how to do this well, or a list like this, it's going to take you a while. And my way, using synthetic division and possibly factoring later on, is actually going to be much faster. Okay, so let's go through some examples. First, we need to list all of the possible rational roots. So factors of 5 are 1 and 5. Factors of 8 are 1, 2, 4, and 8. Okay, so that means I have 1, 2, 4, and 8, because right, all those can be divided by 1, so 1, 2, 4, and 8, plus or minus with all those. And then all those numbers also divided by 5, so plus or minus 1 over 5, plus or minus 2 over 5, plus or minus 4 over 5, plus or minus 8 over 5. That's a lot of numbers to have to try. I don't want to do that. So you're going to try the first one. You can pick whichever one you want to start with. There's no right or wrong answer. I go in order. I do 1, and then I do -1, and then I do 2, and then I do -2. You can start with whichever one you want to. So using my function 5, I'm going to use a positive 1 to the 4th power minus 13, a positive 1 squared plus 8. Oh, look at that, I get 0. That means positive 1 is one of your rational roots. Okay, so now we're going to use synthetic division. If your root is 1, synthetic division is the one where you put the little box here. If the root is 1, you're going to use the number 1. Don't switch your sign if you know the root. And then you write all of the coefficients. However, you need all of the terms. I have a 5x to the 4th, but I don't have an x to the 3rd, so I need a 0, x to the 3rd. Negative 13x squared. I don't have an x, so I need a 0. And then my constant. You have to have all the terms. If you don't have a term, you put a 0 in its place. Put your line down there. You are going to put a plus sign here. Your first one drops down, it's 5. But then to get your next one, it's 1 times 5 is 5. 0 plus 5 is 5. 1 times 5 is 5. Negative 13 plus 5 is negative 8. 1 times negative 8 is negative 8. 0 minus 8 is negative 8. 1 times negative 8 is negative 8. And 8 minus 8 is 0. So now our function is 5x to the 3rd, 1 less, plus 5x, then you just go down, squared, minus 8x, minus 8. You are not supposed to have a remainder because you told me that this is a root. So this should be here. Now, you have a couple of options. Option number 1 is this is not quadratic, so you can continue to plug in your rational roots. Now you would try -1. We already know 1 is a root. Don't try it again. Now we can try -1. And if it doesn't work, go to 2 and then -2 and so on and so forth. Or you could try to factor. This is a 4-term expression. It's really an equation, right? Since z equal to f of x. You could factor that by grouping. If I look at my first two, I have 5x squared is the GCF. That would leave me with an x plus 1. I need this to be x plus 1, so the GCF of negative 8x minus 8 is negative 8, leaves you with an x plus 1. Your two parentheses are supposed to be the same. That then leaves you with x plus 1, and then 5x squared minus 8. Remember, we're technically equal to 0 when we're finding the roots or the zeros. This one is linear. Definitely want to set that equal to 0. This quadratic from the last lesson, it needs to be a binomial. Check. Needs to be a subtraction. Check. Both of these have to be able to square root. Nope. So I'm done. I'm going to set this one equal to 0, which means x equals -1. So what are your rational roots? The one we had up here and the -1 we got here. Now, you didn't know that those are the only two. So if you would have just done the plugging in and checking it, you would have had to keep going. You don't know that there's only 2. I know that there's only 2 because of my math, but you don't know that there's only 2. So you would have to keep checking. But with my way, faster. I know that I'm done now. I am about to run out of time before the bell rings, so I have to stop here. There will be a second video to watch the next 2 examples. Please make sure you watch those 2 examples.